this is a rocket stove that I was building, and it didn't work. So I'm going to go through and talk about how I built it and why it didn't work. So one of the theory behind it is that this is your air tube in here. So air feed comes in here, and then you have a burner inside, and the burner burns and it gets really hot, comes up the chimney, gets really good efficiency, and then you get like no smoke coming out of here. You get very high temperatures, like 1200 degrees to 1600 degrees. Very efficient burning on it. This is your feed tube for putting your twigs in. You don't need much, so you can just put twigs in here. Now what I did is I was going to make a small one, and I used a very small pipe, right? So I don't know, what is that, 1.5 inches or something, right? And it ends up, it's too small. It's really difficult to put a twig in. You know, you get a small twig and you're fighting with it, so the problem is too small. The other problem is really hard to light, right? So in here I've got an angle cut, and I put a little screen in here, and all it did was clog up not big enough firebox, and I couldn't get it to light up and flame well. One of the things you'll notice is I got a nice big thick pipe here, and on the top you can see I have the chimney, right? What I've done in here is, you can see I've put mortar in here, and I was using it as insulated fire brick mortar. And the problem with it is that it's not made for casting as I was using here. Like, it hardens really good here, but I'm pretty sure if I looked inside here, you'd find out that it's still wet, right? So I fired this thing up, and then all of a sudden it started bubbling out here after sitting for over a week, right? So basically, the idea is that if you insulate it all the way up here, you get more efficient burning, you get a hotter temperature out. So basically I had physical problems with this, too small. So this is part one, then I'll build another one, and that'll be part two. So then I'll get into the details of how this is built.
All right, so what's the theory behind a rocket stove? Well, the idea is that you have an air inlet here, and it causes our air, our oxygen, to get into a firebox that's going to burn our tinder or our wood, whatever we're going to have here, pellets. And then the length of this is going to cause a chimney effect, and what you're going to do is you're going to end up having a lot of air rushed in here to supply the fire with oxygen, and it's going to come up through here, and it's going to get really hot, and it's going to go out. The idea is that it's going to be super efficient, as I mentioned before, and we should get like 1200 to 1500 degrees Fahrenheit temperature out of this thing, so that way you get complete combustion. So we have an air inlet, and from the research I've done, I did a lot of reading on the internet, and a lot of people build them, but they don't have a theory behind them. They just sort of throw them together. Read some research papers on it, and the general consensus that I found is that the air inlet tube versus the chimney length, the chimney should be 3 times the air inlet. So in my case, it was 5 inches long here, so from here to here is 15. This is the feed. The feed tube, the idea, you put it at an angle, it becomes self-feeding. You put your twigs and pieces of wood or pellets in here, and it'll actually feed itself. And that some of them are just flat, you just feed them this way, and some this way. If you have it too steep of an angle, then you risk the smoke coming up. When I was testing it, I actually had it burn for a little while, not very good, and part of my testing was just putting my hand over the end here to stop any air from coming in or out. There's no heat coming out of this at all. And that. So we have our air inlet. This area here is our firebox. In my case, what I did is I put a grate down here. We'll see it in the next picture. And we have a chimney coming out. So this is the inside. This is the actual rocket stove part. I used a 1 1/4 inch thick wall square tubing, too small, right off the bat. This is too small. My dimensions were 5 inches, cut at a 45-degree angle, and this is the chimney. It was 15 inches. 3 times 5 is 15. So I would weld this on here to get a nice right angle here. And this was my feed tube, right? And then this was going to sit inside my 2.5 inch thick wall square tubing. This is the top part here, and this is the bottom plate. And the idea behind this is I was going to fill this up with an insulating material. When we look at from this side, what we see is we have our air inlet tube, our feed tube, and then we have our main chimney. On our chimney, we have to cut a little slot in here so that it would mate up with this, so that way we could feed our pieces of wood and little twigs in there. And then what I did is I just took some welding rod and put across here and made a little grate, right? On the sort of, I guess, the insulator case here, I cut a big slot through here, and the idea is that I'd weld up this part and then I'd slide it in from the bottom. I would center the top of the chimney in the hole here on here, and once this was welded and centered, I would feed my insulation from the bottom and then put this cap on here. Right? So we have our air inlet pipe. This part here would be coming here. Our chimney would be inside, and this part here would be here, and we'd have our feed tube. Now this is all welded together, and I'm just getting ready to put on the bottom. I was going to put the mortar in, which I did, which was a bad idea because it's not a casting mortar. It was just a mortar that you use to cement insulating bricks together, and it's a high temperature, right? So this was actually quite difficult to weld in this area, very tight, and over here was very tight also. And this is what it looks like when it's was put together. I left some air holes here because I figured that when it would heat up there would be some sort of liquid in here, and I would let the steam or the gas to escape out of here. My first impulse was to use sand as an insulator. That way you put sand in, heat it up, let it steam out, and that would have worked fine. I happen to have the insulating fire brick mortar around, so I thought I'd try it, and it wasn't a good idea. Well, live and learn on that. Here it is, the top view. These are the holes I left just for steam to come out of it. Again, this is too small an opening, and then end up the firebox was way too small. So I have to go up. The next one I'll use is my 2.5 inch pipe here as the main body for the rocket stove, and then I'll see if I can find a bigger pipe to make the insulating part of it. Some of the things that aren't shown here is it's incomplete. Just in testing I realized this wasn't going to work, but you would want to have a couple legs on here. I would recommend 3 legs. Some people put 4, but 4 is inherently unstable. If you have 3 and you're out camping, then you can have uneven ground, and this would be stable. So I'd have one out back here, one here. And also on the top you'd have to have some sort of support for your frying pan or your cooking utensils, so you'd have to have some area on here. So at this point all I'm doing is I'm just basically testing it to verify that it works. And that, in this case it didn't work, and in part 2 what I'll do is I'll try to build one that does work. All right, thank you for watching.